In this video, I want to do a numerical example where I'll calculate income and substitution effects using a demand function. So let's suppose we have good one and good two. Good two will be a composite good, representing the money we spend on all other goods after spending on good one. Let's take a demand function. Let's say the demand for good one is represented by x1 equals 10 plus our income M divided by 10 times P1. And let's suppose we have income M of $120 and that the price of good one starts out at $3. So what's our demand for good one at this original budget constraint? We would have x1 equals 10 plus 120 divided by 10 times 3, which is 10 plus 120 over 30, which is 10 plus 4, or 14. We get 14 units of x1 under the price of good one being $3. And then how much money is left over? So that's our x2. X2 will be 120, our income, minus our expenditure on good one, which is we buy 14 units at a price of 3. So it'll be 120 minus 14 times 3, which is 42. So it's a total of 78. So that will be this first point here. We buy 14 units of good one, and we have 78 units of good two. Okay, now let's go on to what will happen. I'll do this in blue here. I want to know what happens when the price of good one falls. So P1 will fall to $2. We still have an income of 120. What's our demand for good one and good two? We know that x1 is 10 plus M, which is still 120, divided by 10 times P1, which is 2 now. So we get a demand for a good one, which is 10 plus 120 over 20, or 10 plus 6, which is 16. You get 16 units of good one. How much good two do we get? X2 is 120, our income, minus our expenditure on good one. We get 16 units at a price of $2 each, which is 120 minus 32, which is 88. So that's the second point here. We get 16 units of good one, 88 units of good two after the price change. Now the trick is here, we want to decompose this shift into an income effect and a substitution effect. We're going to start with a substitution effect. Substitution effect says, consider these same relative prices as what we end up with, but let's back it up. Let's say we don't have the income effect. We don't have the purchasing power effect that makes us richer because the price of good one has fallen. Let's take our income back. Let's say we have the same purchasing power as our original bundle. What changes with respect to our demand for good one? That's a substitution effect. So I'll do it in pink down here. Substitution effect says we need to lower the purchasing power that we have, in effect, a lower income. We want to know, where's that pink dot? If we had that lower income, where's our demand for good one falling? Just given those changes to relative prices. I'll label this budget line M prime. M prime says we have a lower purchasing power. How much lower is that purchasing power? We still want to go through this original bundle, but with these new prices. Our P1 will be $2, and we want to just be able to afford that original bundle of $14.78. So our new income, M prime, says we can just afford getting 14 units of good two, which will cost 28, plus 78 units of good two, which costs $78, because good two is just money. And if we add those up, what do we get? 106. So that's going from 106 to 120. That's how much richer in purchasing power, we are made because of this fall of the price from $3 to $2. But we're still not done yet. We still need to find out, where is this point? We now know our new income, it's 106. And the question is, how much do we demand of X1 at this new price and this new income of 106? We just plug and chug. Our X1 will be 10 plus the new income, 106, divided by 10 times the price. Our relative prices are the new ones. So times 2. 10 plus 106 divided by 20 comes out to be 106 divided by 20 is 5.3. Add that to 10, we get 15.3. And how much of good 2 do we have? That'll be our income, 106, minus our expenditure on good 1, which is 15.3, at a price of $2 per 106 minus 15.3 times 2 comes out to be 75.4. 75.4. So that's our point right here in pink. 15.3, 75.4. And you can see after the relative prices changed, good 1 got less expensive compared to good 2, going from this original bundle to the new relative prices. And as a result, we got more of X1 and less of X2, which makes sense because that's the direction that the relative prices were encouraging us to go. And then that's the substitution effect right there. Going from the pink point to the blue point is our income effect. Our income effect said, as a result of the changes in prices, the price of good 1 fell and the price of good 2 stayed the same. We were in effect richer. Our money went further. That income effect, the fact that we felt richer, led us to buy a little bit more X1 and a lot more X2. Our final answer would be, what we wanted to do was to calculate the income and substitution effects. So the substitution effect is that we went from buying 14 of X1 to buying 15.3 of X1. So substitution effect is we bought 1.3 more units of X1. We went from the pink dot to the blue dot. We went from getting 15.3 units of X1 to 16 units of X1. So we got another 0.7 units of X1 just because we felt richer. So that's the final answer there. We can see the income effect is positive, which implies that X1 is a normal good. Demand increases when income increases, which we already knew. We had a formula for demand for X1. It's 10 plus M over 10P1. M is in the numerator, so a higher income means a higher demand for X1. So we actually already knew that X1 is a normal good.